Okay, this question is an example of a Hooke's law problem. So we have a spring which has a natural length of 0.2 meters, and a force of 60 Newton is required to stretch a spring to a length of 0.5 meters. And we want to know the amount of work done in stretching the spring from a length of 0.3 meters to a length of 0.9 meters. So Hooke's law is part of it is going to be f of x equals k times x. Our f of x is going to be 60 newtons equals k times x. And so we know the natural length of the spring is 0.2 meters and that it stretches to 0.5 meters. So the difference is going to be 0.3 meters. So it's going to be your stretched length, 0.5, minus your natural stretched length, 0.2. So we get 0.3. 60 divided by 0.3 would give us 200. So our k value is 200. And now we're going to apply this 200 when we solve for the work for 0.3 and 0.9. So we know the length of 0.3 is actually going to be 0.1 because we're going to do 0.3 minus the natural length. Likewise, for 0.9, we're going to subtract by 0.2 to get 0.7. And we have our k values. We know now our k value is 200. It's 200 times x. So now we take the antiderivative of this. We would get 100x squared. And we will plug in 0.1 and 0.7. And when we do that, we would get 48 joules.